In this video we have the integral of 1 over 4 plus 3x squared. And it is a rational expression, but the denominator isn't really a factor. It's an irreducible quadratic. So partial fractions I don't think would work here. U-substitution would be another option. Now the standard U-substitution, if we had an x in the numerator, that would be perfect. We could let u equal to 4 plus 3x squared, and it would just be a matter of steps here. We don't. Next option, we've done some problems like this before. Let's look at this formula right here. We've used this one before. The integral is in this form here, du over a squared plus u squared. Then the value of that integral is going to be 1 over a arctan of u over a plus c. So next thing we do is, okay, can we use a basic u substitution to get the integral in this format? Now we could have a constant here, that's no problem. But we can just factor it out. So notice for the denominator here, I could write this as the square root of 3. Square it, that'll give me the same thing. So let's let u equal to the square root of 3x. Then du would equal to the derivative of radical 3 times x. That'll just give me square root of 3. And then I have the dx here. Dividing through by radical 3 here, on the right side I would just be left with dx. On the left side I'd get du over the square root of 3. So let's see if we can rewrite it so it fits the formula we just looked at. This would be the integral dx right here would be du over the square root of 3. So there's my du. And then I have the square root of 3, but I'll write that out in front. That's a constant. And then the denominator, I have 4 plus, and right here, radical 3x squared, that's your u. So this will be u squared. So this, the 4 then, I can rewrite the 4 as a squared, or write it as 2 squared. In the formula, it was a squared plus u squared. But all that means is that the a here will equal to 2. Now we can go directly now to the formula. So it's 1 over the square root of 3, and it was arctangent. And this is going to be u over a in the formula. It was 1 over a, and then arctan of u over a. Well, in our case, u is square root of 3 x over a, and a is 2. 4 squared or a squared, 2 squared, a is 2. So this would be 2 here. So again, it's arctan u over a. In our case, a is the square root of 3 times x. A is 2. And then in the formula, it was 1 over a, or the coefficient, divided by a. So this is just divided by 2. Which of course will make this as 1 over 2 radical 3. And this is plus the constant of integration. That's your final answer for this one. 1 over 2 times the square root of 3, arctangent of radical 3x over 2 plus the constant of integration. And you can rationalize this here. Make it as square root of 3 multiplied by radical 3. So you can write this 1 over 2 radical 3 as radical 3 over 6. I'll just leave it in this form here. Thanks for watching. We'll see you next time.